We continue our discussion of logs by expanding on the log properties. And these properties will help us solve lots more equations with logarithms. So to begin with, we're just going to do a quick little review of working with exponents, and then we'll see why we did that. All right, so the review, let's talk about what is x to the fourth times x to the third, okay? So that would be x to the seventh. And the rule when you multiply two variables with exponents, you add the exponents. And I always like to remember why that is, because I think it's pretty easy to remember and it's understandable. So x to the fourth means when you raise something to a power, you're multiplying it by itself. So you're multiplying x to the fourth. That means it's x times x times x times x, right? That equals x to the fourth. And then we're multiplying that by x to the third. So that would be x times x times x, right? So just multiplication. And then you can see that there are 7 x's, and therefore that would be x to the seventh. Okay, and that's why we add the powers. All right, in the same light, we have a to the sixth divided by a squared. And the rule when you divide is that you subtract the exponent. So 6 minus 2 is 4. So this is a to the fourth. Of course, I love to see why that is. So a to the sixth in the numerator means a times a times a times a times a times a 6 times, right? And in the denominator, a squared is a times a. Okay, well, hopefully you know that anything divided by itself is the same as 1, right? So a over a is 1, and a over a is 1. And so when you look at it, you can see what you have left, a to the fourth over 1, so that's just a to the fourth. Now we have x squared divided by x to the fifth. So if we use the rule that you subtract exponents, we would get x to 2 minus 5, the negative third power, right? And that is the same as 1 over x cubed, right? The negative power would bring that to the denominator. And we can just look at how that one works. So that's x squared on the top. So that's x times x on the top. And on the bottom, we have x to the fifth. So 5 x's. 1, 2, 3, 4, 5. Okay. Then we say x over x is 1. X over x is 1. So in this case, we have nothing on the top. In other words, we had x over x, so that's 1. So we have a 1 on the top, and we have 1, 2, 3 x's on the bottom, 1 over x cubed. All right, final exponent rule. A to the third raised to the third again, okay? So this is, I like to call this power of a power because it rings. When it's power of a power, you multiply the exponents. So a to the third raised to the third would be 3 times 3, 9. A to the ninth power, okay? It's easy to see how that is as long as you don't mind writing a lot of a's. A to the third is a times a times a, right? And that is cubed, okay? So what that means is a times a times a times itself 3 times, right? So if you count up, now we're just multiplying, and we have 9 a's we're multiplying together by themselves. So that is equal to a to the ninth. And that's why power of a power, you multiply the exponents. All right, while I've got you here, I'm going to erase all these little explanations. You could keep them. I think you should keep them somewhere so that you can always learn, remember those rules by just checking them out, just trying them. I like that. But I just want to remind you a few other things about exponents because these are the ones that a lot of people have trouble with. So if you have a square root of x, that power is the 1/2 power, okay? How you get fractional powers is the root, Okay, if you have the cube root of x, that is x to the 1/3 power. It's the exact same thing. That's what the root means. So if you have the 5th root of x, and the x is raised to the 2nd power, so the 5th root of x squared is how this would be said. This will be x to the 2/5 power. Okay, the squared is the numerator because that is the power it's raised to. The root is always the denominator. Okay, so likewise, if you had the square root of x to the 5th power, then this would be x to the 5/2 power. Okay, that's just those fractional exponents that you might need when you're doing some of these problems. Okay, so now we've talked about this before a little bit in the definition of logs. The log itself is equal to the exponent in exponential form. So logs are exponents, right? So in other words, they follow the rules of exponents. So let's go through the rules now, and in our next video, we'll do some examples of them. So first, we have the log of a product. And that rule is, if we have the log base A of m times n, you know, I'm not going to put a little dot because if you put 2 letters together, that means times, right? So we could separate that out into 2 logs. That would be log base A of m plus log base A of n. Okay, I know that seems strange. The multiplication means to add, except remember with the exponent rule, when you multiply 2 powers together, you add the exponents. So we're doing the same thing. Logs are exponents, so we're going to add them together. The log of a quotient is log base A of m divided by n, and that is log base A of m, the numerator, minus log base A of n. Okay. The log of a power, log base A of m raised to the b power. Okay, the rule for that one is this power can go out in front. So b times log base A of m. If we have time, I'll show you why that one works with an example in another video. And then we have the inverse property of logs. So in other words, if we have a log, log base A of y equals x, then we can use the inverse to say, well, then a to the x is equal to y. Okay, so this is just being able to change the form back and forth. And remember how we did that with the little the e, or maybe I will show you that when we do these problems. Okay, and then finally, our last property, or this is really a rule we're going to use, is a formula. It's called the change of base formula, and that says log base A of x is equal to log of x divided by log of A. Okay, in other words, it's called the change of base formula because it enables us to change the base from some number to some other number. Remember, if it says log and there's no number listed, remember that that number is, hopefully you're thinking 10, right? So this is really log base 10 of x divided by log base 10 of a. That's helpful for your calculator, right? To be able to type in logs for all calculators. And then you also, there's another common change of base formula that we use, log base a of x. we can turn that into natural log because our calculators also have an ln button. So ln of x divided by ln of a. In this case, we change the base from a to e, right? Because natural log, the base is implied, it is e. We'll do examples in that next video.